Hey guys, welcome back to the channel. So if you're new here, you may want to start with a different video. This is a technical video, an overview of the swiveling screen mount kit that I make for the Tesla Model 3 and Model Y. So if you're new to the channel, I appreciate you tuning in. Hopefully this video will be in some way educational to you. If you were hoping for entertainment, you can watch some of my other videos where I make a fool of myself working on my car and overall talking too much. But for today's video, I wanted to go over the specifics of the production version of my swiveling screen mount kit. So we'll be disassembling this kit, and I want to walk you guys through the how and why of everything as it is. This is mainly being shot because I've had a lot of questions about this. So first off, we'll start with, you notice that it is asymmetrical. That this pivot is offset from center, and if you look, there are two holes bored in the primary foundational component. The reason that there's two holes is left and right drive. Now, I'm holding this to you in the orientation you would be looking at it in the dashboard of your car. So my car is left-hand drive, but this pivot is offset to the rightmost hole. The reason for that is, in a left-hand drive car, you want the screen away from the driver just a slight amount, because when the screen swivels toward the driver, it wants to dive behind the steering wheel just slightly. So what I did is I offset the pivot to one side, and that moves the screen just slightly out of the way of the steering wheel. So when you swivel it toward the driver, it's not blocked by the steering wheel. Now and you'll notice that, again, even though it's left-hand drive, it's in the rightmost hole because I'm moving it to the right side away from the driver. If that's for left-hand drive cars. For right-hand drive cars, this would merely be moved to the left hole. Now I'm trying to remember to assemble them correctly for each market, but if you are a right-hand drive market purchaser and you receive your mount kit and it is these all come pre-assembled, and if you notice that it is in the wrong hole, if you have a right-hand drive car, this should be in the leftmost hole, then all you do is remove this nut and move it over. Now there is a bit to this, so let me explain. When I designed this kit, initially my version 1 mount, which is still available at a discounted price versus this kit, it was designed to lower the screen a little bit and pitch it toward the dashboard and angle it toward the driver a little bit in the same way. I tried to match it as close to what the Model S had as I could. Over time, I had a number of people say that, well, if it would swivel left and right, if I could make it parallel with the dash or adjust it toward me, or maybe even swivel it over to the passenger, I would buy it. So I thought about it and eventually came up with this mount, and you can see that it swivels left and right. Now, on the surface, it seems pretty simple, and it sort of is, but it took a lot of time to figure out. A couple things. First off, the stack height. You can only lower the screen just so far before a number of problems occur. Opening up of the cell phone door, the cell phone dock door, it will contact the bottom and the back of the screen if the screen is too low. Number two, I don't want drivers' knees to be clunking into the corners of the screen, so that was another reason for it. And so I needed to keep the stack height low, but I wanted the screen to be rigid in a fore-aft axis while swiveling left and right. I didn't want it to twist or forward, back, wobble, or up and down at all, so it needed to be very rigid. Now, trying to get a bearing or some pivot in that narrow area that has that kind of strength was proving to be difficult. So what I ended up doing, instead of putting an angular load on a bearing in the hole, was to transfer the angular load to a flat surface. So you'll notice that this component here widens as it gets to the pivot. That was to make enough room to transmit that angular load to that flat surface rather than the pivot. So this thick post, this is a 1/2 inch diameter pivot, that actually doesn't take any angular load at all. In fact, I could have used a far smaller diameter pivot, There's reasons I went with a 1/2 inch, but the angular load and strength of the mount is spread over the flat surface area where this washer resides. And that washer is made of a specific polymer. That took a lot of experimentation. It had to have the right amount of drag left and right. Like for instance, your rear view mirror, you want it to move easy enough that you can adjust it, but have enough drag that it doesn't just jiggle if you touch it or wipe it off or hit a bump. Same thing with this. It needed to have the right amount of drag, but also I wanted to minimize stiction. So for those of you that are familiar with motorcycles with telescopic forks, they talk about the stiction, the amount of binding that the forks have before they start to move. Once telescopic forks are traveling, the movement tends to be nice and smooth and fluid, but initially there's some sticking. That's what happened when I tried fiberglass, I tried G10, I tried carbon fiber, I tried a number of different fibers and metal washers. Is that the screen, I could get the right amount of drag by varying how much tension was on a spring underneath the nut, but all of those materials really had stiction. If I moved it around and then let it sit for a couple minutes and went to grab it, it kind of stuck and then moved. And that stiction was very difficult to eliminate, but I've been able to eliminate it here. You let it sit and it still moves nice and free without stiction, at least none that's noticeable. But then underneath this nut, I needed to keep the stack height low. And initially I had a spring and a nut, and it was really high, and it was unsightly, and the fabric sleeve that wraps around here wouldn't sit flush. So what I had to do was use a low profile nut, shorter stud, but also when you pivot left and right, you'll notice the nut turns left and right. Well, a nut, even a lock nut, will tend to want to loosen if you just have a washer between the nut and the mount. So every time you moved it left and right, the nut wanted to turn just a little bit. So I ended up having to put a ball bearing underneath the nut to reduce the friction on the nut and allow it to spin left and right, and a spring under the nut to put consistent pressure on between these two. If there were no spring between the nut and the bearings underneath it, it would be very hard to get just the right tension on that nut. And once you got it, weather change, temperature change, humidity change, the screen would be far, the friction amount, the amount of load required to swivel the screen left and right would change dramatically. So a spring needs to be installed, needs to be used in order to offset that effect. Well, how do you get a spring in there? Well, you may not be able to tell just by this image, but we have a nut, a spring, and then a thrust bearing, which is comprised of 3 components. So I'm going to go ahead and take this nut off and show you. In case you're wondering, is a 3/4 inch hex. So we'll go ahead and take that nut off. Now, once the nut is removed, then we have the spring. Now, this is called a Belleville spring. I don't know if you can see it there, but it's slightly cone-shaped. And as the nut compresses the center of the Belleville spring, it flattens out the cone shape. And this is actually an extremely short travel spring. I tried wave washers, I tried a bunch of things, but this Belleville spring works best. So that is under the nut, and it is cone side up. Next, we have the thrust washer, and I'm going to pull this out so I can remove the thrust washer in its entirety and show you here. So the thrust bearing has been removed. That thrust bearing is comprised of 3 components: the upper race, the bearing with the needles in it, and the lower race. Now, these 3 components are required for each other because if you just put this bearing down, that thrust washer or that Belleville spring won't catch the rollers correctly, and the rollers will gouge into the aluminum. So you need to have a thrust washer on the bottom and on the top with the needle bearing sandwiched in between. So you can see there's 3 components that stack together for the thrust bearing. It's, I believe, 3.5 or 4 millimeters thick. So that thrust bearing allows the pivot to move left and right without putting any rotational load on the nut, and it allows the nut to be able to remain tightened without without loosening from the swiveling action left and right. So now we have the two components together, and I'll separate the two. And the obvious next component is this washer. And again, this is a specific polymer that is it is chemically stable, thermally stable, and does not gall or stick to aluminum, which was important because these components are aluminum. It slides over the pivot, and you can see that this surface area was machined just right to hold that for that washer. So this surface area is what takes the angular load, not the shaft itself. The angular load is taken by this large surface area and this washer. These washers I had to have custom made. Nobody manufactures these. I had to reach out to a washer manufacturer, tell them the polymer I wanted, the ID and the OD I wanted, the thickness I wanted, the color I wanted. I had to spec everything specifically. Now, next item is the threaded stud. This is a stud that's threaded top and bottom and is smooth shank in the middle. Kind of a simple item, or so you would think. Took me a month. I'd say I spent probably 10 minutes every day for about a month just hunting down the right threaded stud. And I tried various materials. Stainless steel tends to gall against aluminum, and so within that pivot hole, the stainless steel could gall. So I wanted a normal plain steel. Most threaded studs are one particular pitch thread on the top, a different pitch on the bottom. I wanted the same pitch top and bottom. I needed a specific amount of thread on the top, a specific amount of thread on the bottom, and a specific amount of solid shank in the center. That was not easy to find. Now, ultimately, I found it right here in Illinois, the supplier for those, which was a blessing, but it took a lot of time to locate that. Another item is this is a wire guide or a wire retainer. When the screen would normally be mounted here and the dashboard here, the wire harness goes up toward the screen, and when you swivel it back and forth, there's a bending moment that's put on the connector at the screen. Very, very bad for that connector, bad for the screen. Well, initially I thought, well, I'll just use a wraparound wire retainer, till I realized that if you take, once the wire retainer, which would wrap around and screw to this, once that's fastened in place, if you take the screws off the screen wants to hang by that 1 inch of wire, or less than an inch of wire, between this part and the connector. And I thought, well, so they have to remove the wire retainer, then remove the screen. That's, do I put a warning label on it? What do I do? So I came up with this wire guide that when you drop the screen, you take the screws off to take the screen off the mount, the wire harness drops right out of the guide. The wire harness fits snug enough up in here that it holds real well, and it's not going to fall out. The orientation of the wire holds it up in place. But when you take the screen down, the wire pulls right down and out of the way. So that was a bit of an issue, and nobody makes a component like this. So ultimately I had to design it and have it modeled and 3D printed. So that's a 3D printed component that I couldn't find elsewhere. So when all is said and done, every single part of this was either custom made or very unique. The low profile nut isn't custom made, but they're kind of strange. They were tough to find. The thrust bearings are common size, but they're not available just at the corner department store. It's something that I had to locate. The washers were custom made. The pivot is custom made. Obviously the aluminum parts are custom made. The wire retainer is custom made. The fabric sleeve is custom made. There are Velcro tabs that are included with the swiveling kit to hold the screen, the sleeve against the back of the screen. Those were 3D printed also. So it was quite the ordeal hunting down all these components. So though it seems very simple, it is in essence, it was kind of difficult to locate everything that I needed to, and finally gave up and just decided to have most of the parts one-off made for me. And so going back to the mount itself, should you want to disassemble the mount, especially if you want to switch it from right-hand to left-hand drive or vice versa, again, this hole would be for normal, like American left-hand drive cars. Move it there. That would be for, you know, Australia or whatever right-hand drive cars. And so the stack of components, the way it goes together, the base, the thrust washer, then the foundation component that slides into the dash. Then you have your thrust bearing, which is a thrust washer, then the needle bearing, then the upper washer. Then you have the Belleville spring, which again is small side cone upward. And then the retention nut at the top, and then obviously snug that down. And like I said, it's a 3/4 inch socket that's required. So once you get it snugged down, the tension should be about correct. You can adjust the tension should you like by turning this just slightly and then trying to to find that right tension level for you. So that's that. It was an exercise in patience. The version 1 screen mount kit was a lot of experimentation for the machining. This kit was just a whole lot of parts research to find exactly the right individual component for the pivot. Ironically, I've since found another device that uses this same style pivot, which is large surface area to take the angular load, 2 pieces of metal sandwiching a polymer friction washer with a needle bearing on top, a Belleville spring, and a lock nut. And that was a commercial tripod that my son uses. It needed to be repaired. I disassembled it, and it's ironically just a much smaller version of what I came up with here. So for those of you that were curious why it took a long time to release, also the cost involved. Every time I order something, to have the 3D CAD work done and 3D modeling and prototyping and production, I had to buy a certain number of each component. Same with the machining. So there was a lot sort of behind the scenes, but I wanted to show you guys what the finished assembly was, disassemble it so you could see it. Oh, there is no lubrication required whatsoever. In fact, lubrication I think would just lubrication would do nothing more than attract dust and dirt. So I chose to do everything dry. And so if you have any questions, my email will be a link in the description below. And I appreciate all of you guys that have ordered. In case you're wondering, as of the filming of this, goodness, I have filled a third of the pending orders, and I'll be filling orders every single day until I catch up. We're probably going to be continuing to run based on the number of orders coming in and the rate I can fill them. We'll probably be running about 4 weeks out to ship new orders moving forward. And that will probably take us 6 or 8 weeks to catch up on, at which point I expect to have them in stock or at least be able to ship in less than a week. So that's where we're at with it. If you guys have any questions, let me know. But I think that is it. Oh, one last thing is that in an effort to save cost, one of the expenses of having parts machined is final cleanup. When you pull parts out of a CNC milling machine, there's a lot of edge flashing. Even if you chamfer the edges, there's going to be some flashing. There's going to be some burrs. They're oily and just kind of a mess. And so in an effort to keep the cost down for you guys, I had the and to get parts quicker, I had the machinist I've been having him send me batches of parts raw, right out of the machine. I then have to unpackage all of them, clean them all off, take a file and deburr all the edges, clean all of that flashing and all of the metal dust off, pre-assemble, shim, and tension test every kit. So there's a lot to it, a lot of handwork, even though everything is manufactured off-site, other than the sleeves, we make those here. They are cleaned up, pre-assembled, and then packaged here at the house. So anyway, if you guys have any questions, leave them in the comments section below. Thanks, guys. Bye-bye now.